for Moodle, there's a whole section on your course paper. I'm going to go over the difference of proportion stuff first, and then instead of, and then I'll do the using the SDA website and show you how I do Excel quickly, and then talk about the paper, and then whatever time's remaining is yours. Deal? You can ask questions about anything. Okay. Okay. So for the difference of proportions, this is like a combination between a chi-square and a z-score. What I gave you in the handout, the last 5 pages are from a textbook that I used in a different class, and then the first couple of pages I found a really quick example from the internet. I think I stole this from somebody at Penn State. And the way that we talk about proportions is by using this value p. So like x bar is a value for a mean. When we talk about an event happening, we use p for the probability of success. Some textbooks, and this is where math gets really weird, because some people do it one way and some people do it another. Other people, so if this is success, there's usually an alternative, and I don't want to call it failure, although we could. Some people use Q, P and Q. I don't know if it's because they look opposites or what's the deal, but some people use Q. Other people will just say 1 minus P as the rate of failure. And the other way of thinking about this is if P is from a sample, then pi is from the population. So just as we have X and M, the big MU, we have pi as a population parameter. Again, this is one of those stupid things in math where if we could just have one standard, it would be really, really nice. But people use different forms of notation for this. The way that you would use a proportion is if you have an event, so you have 2 groups, and you're asking yourself whether or not, what proportion of that group saw success. Now, you can reframe this any way you want. So I could change these groups, and what I'm going to do for this example is we can change them to genders. And our success could be how often you vote for somebody, or whether or not you voted for somebody. So, for example, did you vote for Bill Clinton in 1996? Oh, crap. Brought the wrong sheet down. I can get the number I need. So the total number of people in my sample is 746 and 981. When it came to voting for Bill Clinton in 1996, the data I have says that 350 men voted for Bill Clinton. And 572 women voted for Bill Clinton. If you looked at the proportions of the two groups, the proportion of voting for Clinton is 0.47, and for women voting for Clinton was 0.58. So it would appear that in our sample, there's about a 13% gap between voting for Clinton between men and women. Geez, if only we had a name to refer to when there's a gap between men and women that's pervasive throughout American politics. Yeah, right? A gender gap. And the question is, what we see in our sample, is this evidence of a gender gap between men and women in their preference for Bill Clinton in 1996? So think about our traditional hypothesis testing. The null hypothesis would say what? What would the null hypothesis say? That men and women are not different, so they're equally likely to have voted for Bill Clinton, right? Our alternative hypothesis is that there's a gap between men and women, and that we're going to see a different result. We believe that this difference of proportions is normally distributed, just like we believe the difference in sample means is normally distributed. So if we want to test this null hypothesis, what we would do is calculate a z-score. But we're dealing with proportions. And first, we need to see the overall expected outcome. So there's this thing called the pooled estimate. And this is it. What this is designed to do is it's designed to capture overall how much success do we think there is. So success here would be voting for Bill Clinton. Well, the pooled estimate is equal to x1 plus x2 divided by n1 plus n2, which is, there were 351 that voted for Clinton. There was 572 females that voted for Clinton. In the sample, there was 746 and 981. Okay. So that gives you your pooled sample. So overall, this is going to give us a success rate for Clinton. The total number of successes is 351 plus 572. Divide that by the total number of cases in our two groups, which is 746 plus 981. That gives us a pooled estimate of 0.53445. Let's just call that 534. This kind of takes the place of a standard error. You still can compute a standard error, and in fact, if you look on the front page, it says where standard error of the difference. You can still compute that. So if you want to do confidence intervals, you would use the standard error. But I want to calculate the z-score, and the z-score has this gnarly equation where I use the pooled estimate. P1 minus P2 square root of P star 1 minus P star 1 over N1 plus 1 over N2. Okay. So what is this? Well, the z is the same, and in fact, what we've got over here is, remember when we were doing this before in the z-score, we'd have observed minus expected, right? So we'd have our observed gap between the mean minus the expected. But what does the null hypothesis tell us that expected gap between the two proportions should be? Equal, right? And equal here means 0. So that's why we don't even include that. Okay. So the first thing we're going to look for is the gap between group 1 and group 2. And that gap was 0.47 minus 0.58 divided by the square root. And we know what P star is. That's our pooled estimate over here. And 1 minus the pooled estimate. And then we're going to multiply it by 1 over the number in the first group, which was 746, plus 1 over the number in the seventh group. And it looks ugly, but with proper calculating, using your calculators, you can go ahead and compute this. And what you're going to get is a z-score that I didn't bring to class. So I guess I can do the calculatoring really quick. How would I get this with a calculator? Well, I'd actually start down here because that's the ugliest thing. So in parentheses 1 divided by 746 plus in parentheses 1 divided by 981. That equals a number. And I'm going to multiply that number here by this number over here, 0.534, and that equals another number, and I got to multiply it by the one in the middle, times 1 minus 0.534, and I end up with a tiny number. 0.000587237. Now, if you unlock your phone and turn it sideways, you can take the square root of that. Of 0.00005872347, and the number I get for all of that mess 0.0242329259. Okay, that's my denominator. My numerator, top, is the gap between the two, 0.47 minus 0.58. So that means what we observed was a gap between the two groups in our sample of 0.11. A negative 0.11. You take that number and you divided it by the denominator, 0.0242329259. I get a z-score he's lost because he was late. So I got a z-score of 4.5. What does that tell us? If you get a z-score of 4.5, what sort of conclusion can we reach about the null hypothesis? We can reject the null hypothesis, right? What do we traditionally use for a critical value of z when we're doing z-scores? No. Well, that's the criteria, but what's the z-score we're looking for? What's the critical value that we're looking for of z that tells us whether or not we reject the null hypothesis or not? It's a z-score. You shouldn't look at any table. You should have memorized this in the last 6 weeks. 1.96. Okay? If you get a z-score that's greater than 1.96, you can reject the null hypothesis at the 0.05 level. Okay? So, looking at the data we had for the is there a gender gap, it would appear that the evidence we see in our sample leads us to believe that in the population there was in fact a gender gap between men and women in the decision to vote for Bill Clinton or not. Okay? And the data tells us that women were more likely to vote for Bill Clinton. The ladies love cool Bill. Okay. This is a difference of proportions test. Okay? It's like a chi-square. It's very similar to a chi-square. Very, very similar to a chi-square. All right. But remember, a chi-square is for when you have, it's preferred to use a chi-square when you have nominal data. Okay? This is actually proportional data. Right? There are numbers there. It's not just a very simple count. Okay? So these are sort of our yes-no kind of questions. All right? These are when we have dummy variables in here. You would use a difference of proportions test. So if in your paper you're looking at a gender gap, this would probably be the way to go. If your data is binary like this, if it's a dummy variable, if it's a yes-no outcome, did you vote for Bill Clinton, yes or no? Okay. Do you believe in spanking your child? Yes or no? And then we can compare two groups.
What if our opinion doesn't necessarily match our data? Would you like our opinion more, or
if your opinion doesn't match your data, what do you mean?
Well, like what you said.
You find Bill Clinton repulsive, personally. It doesn't matter.
Okay.
You're just one data point.
Okay. So you
all right?
wouldn't want to see our opinion at all?
No.
Okay.
I want to know what the data says.
Cool.
Right? Okay. Because that's what we're trying to do, right? We're trying to study a phenomenon outside in the greater world. All right. So if I get a paper, somebody wants to write a,
Any bias?
yeah, right? I don't want your bias.
Okay.
I don't, listen, I can write a paper on things that I find absolutely horrible. I've done that. Okay. Again, a geologist does not have to want to be a rock. Okay, you can study something because you have an interest in it, not because, and in fact, if you agree or disagree with it, I shouldn't even know, right? I just want to know what the data says. So the handout has, there's another example in the handout that I walk through. Males and females were asked about what they would do if they received a $100 bill by mail addressed to their neighbor. How the hell are you going to know? You get, like, you open up your mail and you're like, shit, I got a $100 bill. Who did I get this from? And then you look for the envelope and notice that it has your neighbor's name on it. That ever happened to you? You open up the mail and you're like, hey, I didn't expect this thing. And then you look at the package and it's because it was sent by somebody to somebody else. I got a nice car charger out of it. Things happen, right? My house is like an Amazon warehouse. Like, packages just go in and out of that place every day. I might get one for the neighbor. Again, nice car charger, whatever. All right, so you get a $100 bill in the mail. Also, are we sending cash in the mail anymore? Is that pretty much just a grandma thing? Think so? You guys don't even have cash anyway, so you get $100 in the mail. It's clear that it goes to your neighbor. Would you give it to your neighbor? Okay, so in 200 respondents, of the 69 males who were sampled, 52 said yes, they would return the money. So 52 successes out of 69 trials. Of the 131 females sampled, 120 said yes. So 120 successes out of 131 trials. So I answered this question, and it's 2 steps. 1, calculate the pooled estimate. So overall, how much success was there? Well, overall, not looking at gender, 86% of the time, right? So that's my P star there, my pooled estimate. 86% of the time, our sample returned the money. But let's look at the gap between men and women. So to calculate, the next step was a Z-score. There was a gap between men and women. It was about a 16% gap. So women in our sample, 16% higher of a return rate of the $100. But that's just our sample, right? We want to know how likely is it that we would see a 16% difference in our sample of 200 people if in the population there was no difference. So then using that pooled estimate, right, ran through our Z equation, and I got a Z-score of negative 3.14. I don't even have to look that up, do I? Because it's greater than 1.96. I know that women are more likely to return money that's meant for their neighbor. There was a gender gap here. Why are you looking at me like that? You got it? Okay. So that's how you walk through it. There is the equation up here for confidence intervals. So if you wanted to construct a confidence interval around, some people like to do confidence intervals because if the confidence interval is all on one side, It's both, you have two positive numbers for your upper and lower bound, and it doesn't go across 0. They like to use that as evidence of statistical significance. Okay. So if you were to calculate the confidence interval, it should be, if it is statistically significant, the upper and lower bounds should be negative in this example. Okay. The first 2 pages, like I said, I found on a website from Penn State. I'm like, this is very clear and simple. I'll go through it. And then I thought about it, and I said, well, what if they need more of an explanation? So then the next 5 pages are from a stats book that I've used, where it sort of talks about the theory behind this. And the only thing that I'll point out is nothing is really too different, right? Except that you notice that in this textbook they use the pies instead of p's. Okay. And they talk a little bit more about the concept of the standard error, which we don't really use because we use the pooled estimate instead. But it's not really all that different. Yeah. See, and the last one, actually, we can use the pooled estimate instead of the standard error. You could use either, but yeah. Okay. So I just wanted to show this to you because some of you will try to do a difference of proportion, or excuse me, a difference of means test because you have numbers, but it's not really a number. It's actually a proportion. Because the dependent variable you're looking at, if it's a dummy variable, 0 and 1, you'll say the average score for males is 58. Well, actually, no, it's 0.58, and that's a proportion. And then you'll get the wrong answer. I had a student in a previous semester take her paper to the math lab and and argued with the math lab people because Dr. Wood didn't show us that. Well, I did. She wasn't paying attention, and I explained to her the difference between a mean and a proportion. And she, emailed me back and told me how stupid the people at the math lab were. And I'm like, well, you went in there with data and you insisted that it's this, but it was that. You could go, but every time you go over there, they're like, oh, we'll do this and this and this. It's like, yeah, you can come to me. You can go to them too, but just be prepared for them to tell you, right? Because again, it's a lot of it is, this is a good example of it, right? Like the math lab people are like, well, where's your test of power? Well, Dr. Wood doesn't care about whether or not the test of power for a chi-squared. All Dr. Wood wants to know about is it significant or not? I think people like to show off. It's like, well, I know how to do this thing. You should do it too. Right? And also the names that we use are different. So like I said, in this book, they don't use the p's. They use the pies. Another book uses p's. Right? You're just more likely to be more confused if you go talk to them instead of me. But you are free to go talk to them, sure. But if you go, have like your book or the handout and be like, I want to do this. This is what I'm trying to do. Pooled estimate. Okay. Okay. So that's here in the course paper section. If you haven't found it yet, there's a template for you for the paper. Yeah. So whenever I write a paper, I always start from a blank template because I don't want to do the same 10 things that you have to do to get Word to do something right. So I just use this blank template. And then I thought, well, I'll share it with students so that they can do it. And then I added a little bit more to it. So one of the problems that I've had in the past when students email me their paper, they've emailed me 3 files before. They emailed me the title page, the paper, and then the works cited as 3 separate files. And that is a sign to me that you don't know how to use Word. Because you just have to do things like make the title page be page 0. That's like 4 clicks. Start page numbering at page 1. That's like 4 clicks, right? And then people didn't know what had to go into the paper. Well, my papers generally follow this sort of format, where I start with an introduction, but the very first word of your paper should not be introduction, because it's the first part. By default, it is the introduction, right? Like that, it's redundant. You're just wasting a line. These? Yeah, that's what I like, right? This is just how I write papers. So this is saying, hello, new section. Why do we do this? Why in academic writing do we do sections? Because we don't expect you to read the whole paper, right? If I've got a 750-page Harry Potter book, they have like chapters. But within the chapters, that's it, right? You're in chapter 10, you're in for it until you reach the end point. That's a work of fiction, but this is not. This is academic writing. I've got a literature review, I have a conclusion, the introduction's always first, right? I'm going to take the paper and I'm going to divide it up into sections so that you know, all right, if you want to look at my literature, go to the literature review. If you want to look at my data, go to the data section. If you want to look at my analysis, go to the analysis section. Right? So the first part of your paper is going to be an introduction. This is going to be why I should read your paper. Right? Why is this topic important? This is not, let's see what it's not. It's not you sort of saying, in this paper, I will discuss the following. Like, I'll get that. It's only 5 pages. Right? What it should be is, there is a debate surrounding this topic. Avoid hyperbole. The greatest question in the entire history of mankind is, are men and women different? No, it's not. Gender is a social construct. Get over it. All right. So you're just going to say, why is this important? My dissertation is about rights claims and how people go to courts to ask for their civil rights to be recognized. And the very first paragraph of my dissertation was a story about 2 lesbians who went to get married at midnight because they had finally had the opportunity to. That's it. At 12:01 on da-da-da-da-da, this person and this person got married. They were only able to do so because of court decision. All right. I started my 200-page, 40 model paper with a story about 2 ladies getting married because the court said they could. And they did it as quickly as possible until another court would say they couldn't. So having a reason why this is important in a non-hyperbolic way. The earth will die soon. Okay, too far. All right? But a recent government report indicates that significant effects of global warming or climate change will happen by 2030. Yeah, because it's a thing. Like when I grew up, it was global warming. You're growing up, it should be climate change. It's just like they're no longer homosexuals. They're gays and lesbians. You have to update the LGBTQA plus. Okay? You have to update the terminology. It went from sexual preference to sexual orientation. Because preference implies that you can choose to do this. Just as any person could choose to like broccoli. You can't choose to like broccoli. You can only put it under lots and lots of cheese and butter. At the end of the day, I still don't, well, actually I'm okay with broccoli. It's Brussels sprouts that taste like farts. And they will always do that. And I will never like Brussels sprouts. Because it's not my preference, it's my orientation. Okay. So a literature review. What is a literature review? It's what we already know about this question. And when I say what we already know, it's what has previous published research said about this topic. Now, when I say about this topic, it could be about your dependent variable. Okay. So if I'm writing a paper on gender differences in corporal punishment during child rearing, which is a nice way of saying do men and women spank their kids differently. All right, my literature is going to be on that effect of spanking children. It could be on the history of corporal punishment in the United States. Right, I have to sort of show you, the reader, or show you the grader. Right? Show the professor, the grader, that I know a little bit about this topic. In grad school, when we were dissertating, we would talk about our literature review as a, yeah, I know. Have you seen Marx? Yeah, I know. Right? Have you read the latest Kinder? Yeah, I know. Right? So you would put things in there to say, I've read this. Back off. Okay? It would sort of be like a shield. Your literature review would say, this is what we already know about this topic. This was also our opportunity to poke holes and say, well, we know this, but Smith never talked about that. Right? I wonder. Hull and Brace do a lot of work on this. However, it's just in death penalty cases. Well, I wonder if these findings hold up in other types of cases, such as rights claims cases. Okay, so the literature review is also the time where you can say, this is what we know, this is what we don't know. Not for you guys. For you guys, I just want to see that you've actually done some research on your topic. This is a 5-page paper where you're going to successfully test a hypothesis. This is not for the undergraduate research competition. This is not going to be sent out for publication. This is you saying, I looked into this topic. What this literature review should do is convince me why it's okay that you think your independent variable influences your dependent variable. So if my literature review says that there are lots of instances where men and women think about crime, child rearing, and anything else that exists under the face of this earth differently, that provides evidence for my test in my paper that men and women might think about spanking their children differently. Right? That's my justification for linking those two variables together. Men and women think differently about a whole range of subjects, such as whether or not tubs are required every day. I am pro-tub. My kids need to have the germs knocked off them before they lay down and go to bed. Pro-tub. We all agree with that, right? You got to scrub those kids. Filthy. Okay. However, I do not believe that children need to eat vegetables every day. It's a cumulative thing. All right? Vitamins are good enough. and some fruit. Between vitamins and fruit, the kids will be okay. They're not going to get scurvy. However, other people may disagree. My wife thinks they need to eat vegetables like all the time. It's wrong. Okay. For your 5-page paper, your introduction is going to be half a page, tops. Your literature review, 1.5 pages, 2 pages. Okay? It's not going to take forever. The next part's going to be analysis and assessment. This is where you're going to show me that you learned something in this class. Okay? You're going to tell me what your independent variable is, where it came from, right? What data set you used, how it's measured. You're going to tell me what your dependent variable is, where it came from, how it's measured, why you measure it that way, if you changed it. You're going to talk about your data set, how many observations you have. You're going to tell me what test you're going to use. You're going to tell me what the null hypothesis is, what the alternative research hypothesis is. So in the book where Howard goes 1, 2, 3, 4, 5, 6, like he has that sort of checklist step, you're going to do that in this section. Only you're going to do it in sentences and not like, yeah. Don't worry about the Greek letters so much. It's a different font, essentially. It's a symbol font. It's called Symbol. That's the name of it. Times New Roman. Symbol. It's the font name. Symbol. Yep. If you can't find the sigma, just say sigma. I'll know what you're talking about. Okay? Okay. This is the most important part of the paper. If your paper does not include a clear hypothesis test with clearly identified independent and dependent variables and the calculation of a test statistic, then you will receive a 0 out of 100. I put that there to remind you that this is a statistics class, and your statistics paper should have statistics that you calculate in it. Right? If you put some numbers on the page and you're like, numbers, done. Well, I got a number for you, and it's a 0. I had one student 3 semesters ago, 4 pages of tables. And it's like, I'm done. It's like, well, you have no hypothesis testing. You don't even clearly tell me which ones are the independent and dependent variables. And at no time do you actually test those two things together in the same space. Yes, there are a lot of men in the sample. Yes, a lot of the people like this. But that does not necessarily mean that a lot of the people who like it were men. Crosstabs. Didn't do anything like that. 0. What was the first complaint I got from the student? But I did a lot of work. Okay. But you didn't do a lot of statistics work. And the statistics work were what will get you the points. Not a lot of useless work. So, yes, you'll get a 0. I guarantee, probably of the 17 people that turn in a paper, at least 2 of them will get a 0. They're not here right now, so it probably won't be any of you. But somebody will turn in a paper with a table and says, look, more men than women voted for Bill, or more women than men voted for Bill Clinton. It's in the table. And I'll go, where's your difference of proportions test? Or where's your incorrect chi-square? Or where's your incorrect difference of means test? Like, you could have done it right one way, you could have done it wrong 2 more ways, but you didn't do anything in there. So you get a 0. If you do something, but you do it wrong, I'll at least give you a 50 out of 100. You'll salvage some portion of it. But you have to do it correctly. The number one way to do it incorrectly is to use the wrong test. Right? I know how to do this one thing. I'll do that thing, and it'll be okay. Because I'll have all the other stuff he wants. I'll have the null hypothesis. I'll have this. I'll have that. I'll even, reject the null. That sounds familiar. And it's great. You got a 50. You're in the ballpark, but you don't know what you're doing. I had to add this clause. You may not reference statistics generated by others. Somebody thought it was okay to report the results of a paper from their literature review, as if they did it. First of all, the reports that they reported, I didn't teach in class. Second of all, it's really shady, and you should not do that. Only the papers that clearly demonstrate competence with the methods taught in class will receive a passing grade. So your analysis and assessment should be a couple of pages, depending upon, if you do tables and whatnot. If you're nervous and you want to literally staple your hand calculations to the end of the paper, go ahead and do that. Fine with that. I got no problem. If you've got 50 pages of you trying to figure out how to do a chi-square, go ahead. Staple it in there. However, you're uploading these online, so make sure you bring me a copy of it.
Would you like our Excel?
As if you want to print it out and staple it to it, yeah.
Okay. Would you prefer?
I don't care how you do it. This is just to make you feel better. Right? Finally, what do you do in a conclusion? This is where you explain to me what meaning we can get from your rejecting of the null hypothesis. So it's not just enough to say, we rejected the null hypothesis, therefore there's a gender gap. Give me a couple of sentences that explains that.
So basically, when we did that one test, the parking,
Mm-hmm.
so how after our conclusion, we said that there's not really a time gap, 9 seconds or something.
You could talk about that. Yeah, you can place sort of the relative difference of your findings in context, right? If I remember correctly from that one, they talked about how this result aligned up with other results about territorial something or other, right? That parking was an example of territorial dominance, was it? Right? Even though, in their instance, this was something that you didn't own. And so they extended that finding of territorial dominance to places that you temporarily occupy. Which when I go back to where I went to college, I went go by the houses that I used to live in, and I'm like, hey, this is my house. I haven't lived in that house for over 20 years.
So all that was content.
That's in your conclusion, yeah. All right? So that's what the paper is going to look like. Yes. Okay. Anything else about what the paper is going to look like? Okay. So this is available to you. I highly suggest you use it. Don't forget to write your name and the title. Change this stuff down here. Okay. What else is up there on Moodle? Yep. All right. Also on Moodle, there's 2 video demos. One is using the SDA website. The main thing you need to be able to do from the SDA website is I need to remind myself it's sex and spanking. Okay. So up here, there's a button that says download custom subset. All right. This will allow you to download an Excel file that has every observation as a row in the spreadsheet. You want to download it as a comma-separated values, a CFV. This will make it easiest for Excel to read it. Select cases to include in the subset. Okay. You might want to consider, if you have a variable that has 200,000 responses, looking at different years. Because with the GSS, it goes from the 70s all the way up to recent years. Maybe you want to, I don't know, do this by decade. Maybe you want to do 1 year in the 70s, 1 year in the 80s, 1 year in the 90s, 1 year in the 2000s. All right. Maybe you want to do it once every generation. Do 2 or 3 generations. All right. I'll tell you what, if you download all 100,000+ observations, you'll pretty much find statistical significance in anything you look at, because the standard error will be so small. Okay. So you might want to, like I said, you might want to sort it maybe by year. Pick 1 year to look at, or a range of years. Maybe you think that this effect is, here's an A-type paper. You're looking at something and you want to know if the effect diminishes the further away you get from an event. So an event like 9/11. So you want to know if nationalism or patriotism is really high in 2002 and whether it changes as we get closer, as we get further away from 9/11. Maybe you want to look at before 9/11 and after 9/11. All right, and you want to compare the two to see if they're the same. All right. So you can use the selection filter and say, I want year 2008 only. Or I want this range. I want year 2002 through 2016. Right. That's sort of your generation of peoples. We're getting to the point where my freshmen were born after 9/11. It's really weird. Like, it's really, really, really weird, especially in politics. Select the variables. I want sex and spanking. Bonus points for you for not laughing. I hit create file. I got to double check and make sure I got the right files. So it's going to download these 3 variables for me. Case ID, sex, and spanking. Okay, that's what I was looking for. Create the files. And then all I have to do is download the file. And here it is. I'm going to hit show in folder so that way I know where it is. This is my downloads folder. That's where it put it. And I don't want to keep it there. I want to put it someplace else. So for now, I'll temporarily just put it on my desktop. There it is. And I'm actually going to open it with Excel. Let me go back to Excel. File. Open. Oh, desktop. Now I need to do, let's make sure it's, what was the name of that stupid thing again? I got to do all files. Sorry. Because remember, it downloaded it as a text file. And Excel goes, wait a minute, this isn't an Excel file. How am I going to open this? Well, there's a character, like a comma, that separates the rows and the columns. It's a comma. Yep, this looks like my data. Finished. Okay. Now I've got a raw data set. What can I do from here? Well, now if I want to change a variable, if I want to delete cases that I don't want in the data set, right, I'll sort them by these numbers, because these numbers represent specific values. Always remember that when you sort your data, you want to make sure you select all of it, because you can't just sort one row at a time. So if I sort my sex column and not my spanking column, it'll ruin your data. It'll essentially only sort these ones, and it'll keep these values the same. That's bad. Okay. So in the file that I just downloaded, for the spanking, I have actually 4 responses that are of interest to me. Do you strongly agree, disagree, or strongly disagree that it is sometimes necessary to discipline a child with a good, hard spanking? About 73% either agree or strongly agree. And about 26.5% disagree. What could I do to that variable to analyze it? Well, if I'm doing it by gender, I've got my 2 groups, right? Is there a difference between men and women? But would I calculate a mean? Let me reframe that, okay? Could I calculate the mean response for my for my column of numbers that are 1, 2, 3s, and 4s? Yes, I can do that, right? I can calculate what the mean value of spanking is. And what if I told you that the mean value of spanking was 1.7? What does that mean? So the average spanking score is 1.7. Does that tell you anything? No, right? It doesn't tell you anything. Because these 4 things are actually categories. They're ordered categories. They're ordinal, right? They go from I guess, most agree to least agree. But the number itself, 1.7, doesn't tell you anything. 1.7 is not. So it just tells you that the majority are somewhere between agree and strongly agree. Right? So if you were to do that in your paper and then do a difference of means test, you would be doing something wrong. right? Because the value of the mean doesn't make any sense. Okay. So I can't use a difference of means test. Could I use a chi-square? I could, except I have one problem, right? If I do a chi-square, I'm taking that ordinal relationship away. And I'm just saying that agrees a group, strongly agrees a group, right? It's like blue, yellow, gray. Like there's no relationship among the outcomes. This is what I would do. I don't know really how much distance there is between strongly agree and agree. Like, what is the strongly agree person up to? Like, not only do I believe in spanking, but I have a ritual. I got to paddle, right? I got to process. I got to make sure I stretch ahead of time before I do the paddling. Right? Is this like Handmaid's Tale level of like, you have done this wrong and you will receive 3 paddlings? Or just somebody's like, yeah, whoop his ass. Do it with your kids, do it with your dogs, whatever. Okay? So for me, because I don't really know what the gap is between strongly agree and agree, I'm going to collapse these 2 variables down into 2 categories. You either agree with spanking or you disagree with it. So what I do is I recode the 1s and the 2s to 1s, the 3s and the 4s to 0s, and the 0s, the 8s, and the 9s, I delete. They're of no use to me. Those people go away. And so now I have a 0, 1 variable that I can do a difference of proportions test on. Okay. I taught you how to do all of these things by hand. You can do them by hand. You can also let Excel do the work if you've got 60,000 observations. But Excel doesn't really know what it's doing. It just says, it's a number. I'll give you some statistics. So, right, I just highlighted this section of the gender variable, and 1.5 is the average. Now, 1.5 doesn't make sense when we talk about gender, but 1.5 is the average. Excel doesn't care what it is. It just says, it's numbers. I can do that. So you can compute an average. You can compute a standard deviation. So that way you don't have to do that awful table by hand. Okay? And then when it comes to proportions, again, proportions are just averages. So if you take the average of all the males and the average of all the females, that's actually the proportion. Or you also notice that there's this count here. It tells you you have this many of these variables. So you can use Excel to handle all of to get the numbers you need to run your statistics. You can also use the SDA website. You can have it create a crosstab for you. In analysis, I want a table where I want the rows to be sex and I want the columns to be spanking. One thing about this, though, it does more to your data than you know. There's these things called weightings that you need to turn off. And you actually want the actual numbers, the unweighted numbers. Okay, so here's the table that I would need to create the information I need for my difference of proportions test. All right, I can do this, right? I can just add these 2 numbers together and these 2 numbers together and say that's my agree and disagree for my men, my agree for my disagree for women. There's my total row numbers. If I just use this raw data, 10 minutes and I'm done. And that's the thing that pisses me off about these papers, is that they don't take a lot of time if you know what you're doing. If you don't know what you're doing, you fumble around in the woods for 3 days, and the next thing I know, like, we might find your body somewhere. And you end up, giving me 14 of these and not really knowing what to do with any of them. That's what a student did. They gave me this table 14 times. One for 2008, one for 2009. Like, they just did it for every year available. But they didn't actually take the raw data, the numbers, and do a test. So that's what I want you to do, is do a test. Last thing, final exam, study guide's already there.